So remember, the second form of iron, dietary iron, is heme. So that's ferrous Fe2 plus iron bound to heme. So heme iron, which is porphyrin iron, the porphyrin group of hemoglobin, it's imported into the enterocyte by heme carrier protein 1, HCP1. So you can compare this to the way that Fe3 plus is imported in, because that's imported in by divalent metal transporter. So this time it's HCP1, heme carrier protein. Once inside the intestinal cell, the enterocyte, it's broken down by heme oxygenase 1, HO1. And that breaks it down into biliverdin, which is green, and Fe2 plus iron. And it forms the same iron pool inside the enterocyte as with Fe3 plus. And once inside, it's bound to ferritin for inert iron storage, or it's effluxed by ferroportin. And again, we can see that in the diagram. So heme Fe is imported into the enterocyte by HCP1, heme carrier protein 1. There it's broken down by HO1, heme oxygenase 1, to give us Fe2 plus, bound to ferritin for inert storage, and effluxed by ferroportin. Now there's also two forms of non-enterocyte iron transport. So for example, we have blood hemoglobin transport. Hemoglobin in the blood is bound to something called haptoglobin, and haptoglobin directs it to macrophages for breakdown into biliverdin and iron. And we also have blood heme transport. So remember, the heme is part of the dietary iron that we've absorbed in the form Fe2 plus bound to heme, and that can either enter the enterocytes and be broken down, or it can enter the blood directly as well. So in the blood, it's bound to something called hemopexin. And hemopexin does a similar thing. It directs it to the hepatocytes, the liver cells, for breakdown into iron. Hemoglobin is broken down by hemoglobin oxygenase 1 to biliverdin and iron, as we saw. So if you get a hemoglobin, HO1 breaks it down to give us iron and biliverdin, which is green. Then biliverdin is converted to unconjugated bilirubin. And so therefore, if you have too much hemoglobin breakdown called hemolysis, if you have hemolysis, which is too much, then that is one of the causes of jaundice, hyperbilirubinemia. Another concept you need to understand is that heme can also be made, and heme synthesis requires various enzymes. So you don't really need to know this part, but this part you need to know. So heme comes from succinyl-CoA and glycine. Lots of enzymes are required to make an intermediate, and the intermediate becomes heme, which is the porphyrin group of hemoglobin, remember, by an enzyme called uroporphyrin decarboxylase. So it's making the porphyrin group, which is heme, right? And this can be, as we can see here, this enzyme can be inhibited if you have PCT, which I'm going to explain in a second. Now PCT is porphyria cutanea tarda. And it's a mutation in this enzyme. It's a mutation in the gene causing this enzyme to not work properly. So it's inhibits, essentially, uroporphyrin decarboxylase from converting this enzyme to heme. So if you have PCT, porphyria cutanea tarda, and you've got this mutation that means this enzyme's not working properly, then what's going to happen? Well, first of all, you're not going to get enough heme. And secondly, you're going to get a build-up of this intermediate, because this is being converted to this, but this intermediate is not becoming the heme group. So you're going to get a build-up of this intermediate. And this gives you some weird symptoms. So if you have PCT, then the uroporphyrinogen decarboxylase, which is it's the proenzyme forming this enzyme, that's mutated and doesn't work properly. So therefore you'll get a build-up of the intermediate, and that'll give you symptoms which are similar to werewolves and vampires. Your skin will become sensitive to light, you'll get excess hair, and you also have a change in urine colour. So I've summarised that here as PCT causes a heme intermediate build-up, causing vampire/werewolf symptoms.